So friends, let us do one different application, means problem from mensuration. It's a different application. Why I said, because even before also we have seen the combination of three circles, but here it is somehow different, because in previous cases what we did is, for equal circles we combined, means circles of equal radii are combined together. Combined in the sense each are touching another two. In such a way that arrangement was done. Okay, but now here the bigger two circles are equal, and this is another one is small circle. That means only two circles are congruent, means two circle radii are equal, and rest of one circle is unequal to them. Right? First thing is that we need to identify. The next one is, see, what is our target to find? Just in the given diagram, big circles are congruent, and radius of each big circle is how much? √2 plus 1. And the radius of the another small circle is 1 centimeter. Then find the red color shaded region between the circles. That is our question. Okay, let us do. Okay, let us do it. So what is given in this? Our required information is, for these two big circles, these are congruent. Congruent in the sense those radius of those circles are equal, and radius of each one is how much? √2 plus 1 centimeters. Second thing, here small circle means small blue colored circle is there, no? For that radius is 1 centimeter, and we need to find out the red colored shaded region. Red colored shaded region in the sense this shaded region which is in between them, this shaded region, we have to find it out. The same thing we have done in case of three congruent circles. Do you remember that or not? Same thing we have done in case of what? Congruent circles, means equal circles, but these circles are not equal, no? So anyways, whatever is given, we have to move from beginning only. What is the we have to begin from which point? We have to join the centers of the circles. First the thing is that we have to do. Okay, let us do it. Let this be centers. Let us assume these are the centers. Not exactly, we are assuming these are the centers. Okay, so now let us join the centers. Now we join the centers. So here the centers are joined together. Anyhow, it came to know that there is a triangle formed. Okay, it formed a triangle. Okay, till this everything. Okay, till now we are doing this procedure only. In case of all the equal circles also we have done the same thing. There is no difference at all. Okay. So now also we are following the same thing, but the difference between those two, this is all the circles are equal, then triangle formed will be equilateral. But can we say that it's an equilateral triangle? No, because it's because here one circle radius is different. Definitely, what type of triangle will be formed? There is no confirmation till now, but it's definitely not an equilateral triangle. Okay. So, and one more thing, what is required thing? What is our target to find finally? We have to find out the red colored shaded region. To find out the red colored shaded region, what do we need? See, once again we analyze this. See, this is a triangle. From this triangle area, see again the same thing as before. This is one sector, and this is another sector, and this is another sector. This is another sector. Okay, so now here how many sectors are there? 3 sectors. So we need to subtract the sum of the area of this and this and this. See, this sector and this sector and this sector should be subtracted from this green colored triangle. Is that right or not? So finally our target is to subtract the 3 sectors from triangle. Same as before. Okay, but here the different thing is, See how to find out the area of the triangle first, because to find out the area of the triangle, it depends on types of triangle, because what type of triangle is that we don't know, but it is not an equilateral triangle, we confirmed it. So we have to know whether what type of triangle is that, because you know from the mensuration basics that depending upon type of the triangle, formulas differs for finding the area. Okay, so first of all we need to identify what type of the triangle is that, and we have to find out the area of the triangle with the concerned formula, first thing. Second thing, we have to identify that here to find out the sector area, what the things are required over there. Here the first one is radius and the second one is angle of sector. Okay, so angle of sector should be known and radius. Radii are of course given in the problem, but angles are not given, no. And it's not an equilateral triangle also, so that we can think that all the angles are equal, each is 60. So here angles are unknown. So first of all, to fulfill these two aspects, I am telling you what are the requirements. We need to know what type of triangle it is to find out the area of triangle first. And second thing, we need to find out the angles of triangles also, because those are the angles of sectors. Unless we have the angles of sectors, we can't find the areas of sectors. So we need to know the type of the triangle and we need to find out the angles made in the triangle. Okay, to fulfill these two targets, we have to study the property of triangle. First of all, let us do this. Now, so this is the triangle which is obtained by joining the centers. Now let us note down the radii of each of the circles. So tell me, this small circle radius is 1 centimeter or not? So here 1 centimeter. 1 centimeter means, let us write it down. So 1 centimeter, this is 1 and this is 1. And bigger circle radius of each is root 2 plus 1. This is the root 2 plus 1 centimeters. Okay. So from this, we have to get the things from here. Finally, this total, this length of this total side would be 1 plus root 2 plus 1 or not? Root 2 plus 1 would be root 2 plus 2 or not? So this is root 2 plus 2. Same as that, here root 2 plus 1 and 1. That also would be root 2 plus 2 or not? Root 2 plus 2. So one thing guys, it is confirmed that it's an isosceles triangle. Get it or not? Because two sides are already became same. Third side will never be equal. Why? Because radius of the third circle is not equal to remaining two. So anyways, this is isosceles. First thing is confirmed. Okay, let us go for next analysis. Okay, see here. Here this is total root 2 plus 1, this radius, and this radius is root 2 plus 1. Then length of this total side would be this plus this or not? What is that total length? Root 2 plus root 2, that is 2 root 2. And 1 plus 1 would be 2. So what is the total length of this? 2 root 2 plus 2. Got it or not? Nice. So now let us rearrange this. Let us do the rearrangement of this. See, we'll modify. 2 root 2 plus 2 can be written as root 2 whole square or not? Applying the square and square root also at the same time, so that its value remains same. So that means root 2 square I wrote here. Okay, root 2 square when I wrote here, root 2 square means square and root will be cut down, then definitely it will be 2 only, no. So value is not going to change. Okay, now from this, here root 2 is common in two terms or not? Now can we take common that or not? So what is that? Tell me, root 2 we are taking common. Here 2 will be left and here root 2, right? So here this is finally this bigger side. Is that right or not? Let us write here. So what is this? What is this side? Tell me. Root 2 into 2 plus root 2. Getting my point or not? Now listen to me, guys. These two sides are equal or not? If this is A, this is also A or not? This is A, this is also A, because both are same. Next, then what is the form of this side? Tell me. This is in the form of root 2 into A again or not? Root 2 plus 2 or 2 plus root 2 is same or not? So what we said here, if this is A, then this is root 2 into A or not? So this type of measurements will be available in which type of triangle? If this is A, this is A, this is root 2A, this is that pattern only, no. So this type of measurements are there in only right angled isosceles triangle. It is right isosceles triangle obviously, but other than that it is right angle triangle also. Why? Because in right angle triangle, what is the major property of right angled isosceles from the basics of mensuration? In the basics of mensuration, we teach that if perpendicular sides of right angled isosceles are A and A each, then what is the length of its hypotenuse? Root 2A, means hypotenuse is root 2 times of side in right angled isosceles triangle. Is this right or not? So this is right. So here this is right angled isosceles triangle. So when right angled isosceles triangle, this is A, then this would be root 2A. Okay. From the basics of, see how it is root 2A means nothing. Here if this is a right angle triangle, no, we can apply the Pythagoras theorem for that. Okay, this side will be equal to, is this hypotenuse or not? Hypotenuse equal to, suppose, let us suppose this is x. Applying the Pythagoras theorem, then we get this. Means under square root A square plus A square. Is that right or not? This is a hypotenuse and its value would be under square root A square plus A square. How much is that? Root 2 A square. Why? Because A square 2A square. So A square comes out, becomes A, and root 2 will be left inside the square root. So that will be root 2A. Like that I am telling you root 2A. It's not blind answer. Understood? So anyways, we don't need these all. Here our result is just if side is A, then hypotenuse is root 2A in which triangle? In right angled isosceles triangle. Here this is A, and this is root 2A. Why? Because this is root 2 plus 2, this is root 2 plus root 2, this is root 2 into root 2 plus root 2. That means this is A, this is root 2A. This is right angled isosceles triangle. Clear for you people or not? So first thing is clear that this is a right angled isosceles triangle. So what is the area of right angled isosceles triangle? If A is a side. If side is A, what is the area of right angled isosceles triangle? Let us see. Okay, right angled isosceles triangle area would be, when A is a side, then its area would be, area of the triangle would be what? Half A square. This is also from the basics. Half BH. B and H are same, no? So half A into A. Half into base into height. Half A into base into height. Half into this is base into this is height. So that is half A square. So for right angle isosceles triangle, the area would be half A square. So now so what is this side finally? Root 2 plus 2 or not? And this angle would be 90 degrees or not? So here also this total side is root 2 plus 2. Got it? Now what can be the area of triangle? Area of the triangle equal to half into side square. half into side square means this side is root 2 plus 2. So that is half into root 2 plus 2 whole square. And here also I am doing one small arrangement because according to options we have to adjust the answer. Okay, here answer can be represented in 2 or 3 ways, but according to options we have to adjust. For that purpose I am doing something. See, again this root 2 can be rearranged at root 2 whole square or not. This 2, this is 2, root 2 plus 2 inside the bracket. This 2 can be written as root 2 whole square or not. Squaring and square rooting. Okay, so what happens? 1 by 2 into root 2 plus this 2 is written as root 2 whole square, to that again whole square. Keep this in your mind. Next, root 2 can be taken common from both the terms or not? Let us do it. So 1 by 2 into inside the brackets root 2 is taken common. Here 1 is left and here root 2 square means 2 root 2's are there. 1 we taken out. Now 1 is left inside. So that is 1 root 2 is there. For them all whole square. Getting my point or not? So now what is the final thing? This is 1 by 2 and now tell me this square can be applied for this root 2 and this 1 plus root 2. So now this is root 2 square, that would be 2 into 1 plus root 2, that is root 2 plus 1 we can write. Root 2 plus 1 whole square, these 2's are getting cancelled, and what is the area of the triangle? Finally, root 2 plus 1 whole square. Root 2 plus 1 whole square is area of the triangle. We could find it. Okay, now what is our next task? Okay, what is our next task? We need to find out sum of the areas of these 3 sectors. Getting or not? These 3 sectors we need to find. For that we need radius are given, and now we need to have the angles also. Okay, now let us see. Okay, now we said that area of the triangle is root 2 plus 1 whole square. For an instance I am keeping this result aside. Keep it like this. Now let us move on to next. What is our next task? We have to find out the areas of the sectors. For that we need angles also. Friends, we said that this is what type of triangle? Right angled isosceles triangle. As we said, I got in the property. Now in right angled isosceles triangle, what about the remaining 2 angles? Equal or not? Why? Because there is a property in the geometry. If 2 sides are equal, then opposite angles to those sides are also equal. Means angles opposite to this side is this, angle opposite to this side is this. These 2 angles also must be same when these 2 sides are equal. Okay, so now just see here, this is 90 degrees. Okay friends, tell me what is the sum of angle sum property? Angle sum property means sum of the angles in a triangle is 180 degrees or not. Out of that, here only one angle is 90 degrees. How much of the rest part is remained? 90 degrees or not? Now this 90 degrees is splitted. See here, these 2 sides are equal or not? These 2 sides are equal. So the opposite angles to these 2 sides are also equal. So here 90 is already obtained. So remaining 2 angles should be distributed in 90 only. 90 is distributed equally. So 90 is distributed equally means this is 45 and this is 45 degrees. Clear? Now again go on to the diagram. Now see here, this is the radius of first circle or not. Let us suppose we are differentiating like this. This is the radius. Suppose this is a first circle sector. Sector obtained by small circle. Sector obtained by small circle. Then this radius would be what? 1 centimeter. Okay, 1 centimeter. Next, now again here also these are two sectors here. So let us join these two also. Here these are two more sectors, means one sector is this one and another sector is this one, and we need to find out the shaded portion in between them. This is our target, right? So we have to find it out. So what we have to do? We have to find out the areas of these sectors and we need to subtract from area of the triangle. Get it? Now already 45 degrees is a angle made at the sector, means at the corner of triangle, which is the angle of sector. Now the radius of these circles would be root 2 plus 1, and this is also what? Root 2 plus 1. Is that right or not? This is root 2 plus 1. This is root 2 plus 1. Is that right? Or this radius, this radius, this radius, this radius, all are what? Root 2 plus 1s or not? That's it. Root 2 plus 1. So now we know the radius of the sectors and we know the angles of the sectors also. Then we need to find out sum of the areas of all the three sectors. Before finding, once again I want to clarify you that here these two sectors are of equal size, because here angle made by the sectors are also equal, 45 and 45, and radii of the sectors are also equal. Each one is root 2 plus 1 and root 2 plus 1. So definitely areas also would be same or not? For these two bigger sectors, areas are same. When areas are same, we can find out the area of one and make it double. Then we can sum the areas of these two. Find the sum of these two areas. And we need to find out the area of this separately. Means 90 degree sector separately. Let us find it out. Okay. What are the areas? For example, area of this bigger sector, each one. So what is the area of big sector? Area of big sector is, area of the bigger sector is how much? Each one is 45. Okay, what is the area of sector? Theta by 360 into pi r square. What is theta? I'll tell you for those guys who don't know the basics. This is theta, means angle made at the center of the sector, means angle subtended by the sector, and r is the radius. Then what is the formula to find out the sector area? That is theta by 360 degrees into pi r square, right? Is that right or not? Now let us do the problem. Let's do the problem. What is that? What is theta value here? What is theta value? 45 degrees by 360 degrees into pi r square. Pi into, okay, r is how much? Root 2 plus 1 or not? This is root 2 plus 1 or not? See, just see here, this is root 2 plus 1. So root 2 plus 1 whole square. 45 by 360 means how many times it cuts? 8 times or not? Very simple thing. You don't need to go for tables. If it is 90, okay, 90 means it will go for 4 times. 94 sir. 45 is the half of the 90. So it will cut double times. 4 to 8 times. That's it. Or otherwise you can go through the tables also. You can cut one after one, but go with the higher speed calculations. That's it. So what is that? Here finally area of the each bigger sector is pi by 8 into root 2 plus 1 whole square. This is area of each bigger sector. Getting my point or not? Right. Next. Now we need to find out the area of small sector also. I am keeping this result. See, area of big sector equal to pi by 8 times of root 2 plus 1 whole square. we kept it aside again. Now we just do the problem. Now we need to find out which one. We have to find out the area of this small sector with angle 90 degrees. So what is the area of this sector? Theta by 360. Theta by 360 in the sense what? 90 by 360 into pi r square. Is that right or not? Theta by 360 into pi r square. Theta means here 90 degrees, and 360, 90 by 360 into pi. R is how much here? 1 or not? So 1 square. So how much is that? 94s are. So this is pi into 1 square, pi by 4. That is pi by 4 or not? Pi by 4. Small sector area is pi by 4, and each big sector is pi by 8 into root 2 plus 1 whole square, and area of the triangle obtained is root 2 plus 1 whole square. We got all these three or not? Now what is our next step of doing? See here, which of the next step we have to take now? Here we have to subtract sum of the areas of these all sectors. Sector means this sector, and this sector should be subtracted from triangle area. So in order to find out the red color shaded region in the sense in the diagram, this one, we need to obtain that. So let us write it down. Now what we need to do? We have to find out area of the shaded region. Area of the shaded region is equal to area of the triangle. Area of the triangle we got how much? Okay, area of the triangle we got root 2 plus 1 whole square or not. From the previous result we got. Okay, what is the area of the triangle we obtained now in this problem? Root 2 plus 1 whole square or not? Minus, just see here, you need to take care of only small thing. Here we need to subtract, okay, from this triangle, that is this one, area of this triangle, that is this one. From this we need to subtract the areas of this plus this. Anyways, these two sectors of radius root 2 plus 1 each, these two sectors of radius root 2 plus 1 each is same or not? So what can we do? We have to double the area of this sector, and we can write here that will be sum of the areas of these two sectors. Now let us write down sum of the areas of these two sectors. Each sector area is pi by 8 into root 2 plus 1 whole square. Got it? Each sector area we got in our problem was pi by 8 into root 2 plus 1 whole square. Now only we got, like how many sectors are there? 2 sectors. So 2 sectors area would be into 2, and now the sum of these two areas is obtained. Now we need to add this one also in that. No, what is the area of this sector? Pi by 4 or not? Just now only we obtained. Okay, pi by 4. Now we need to simplify this. What do we get? 2 4s are. Now multiply with this minus with every term. Now tell me, this is root 2 plus 1 whole square minus into plus will be minus pi by 4 into root 2 plus 1 whole square, minus into plus will be again minus. So here pi by 4. Now according to our arrangement pattern in the answer, better we take common root 2 plus 1 whole square from these two terms. So what is final answer then? Root 2 plus 1 answer we are root 2 plus 1 whole square we are taking common. Now here 1 is left or not? 1 minus, here root 2 plus 1 square is taken common. Okay, now what is left here? Pi by 4, and remaining term is minus pi by 4. So what is your final answer in this question? Root 2 plus 1 whole square into 1 minus pi by 4 minus pi by 4. Is that your answer or not? So tell me, which of the options out of the given ones is correct? Just see, Here I think it seems like this. So your answer would be option B. Okay, your answer is option B. So my dear friends, sometimes this type of problems also might be given. You should be mentally ready to do any sort of problem. Okay, lot of students are fixed to certain models only. If those are given in the exams, they will do. Otherwise, they will just leave it off. That's not correct, because nowadays all the exam patterns are updated and models of the problems are quite unpredictable. So at that time, if you are there only in old models, then you may not be get survive and you may lose your job. Please try to update yourself and try to do the difficult problems also. We also will provide more number of videos with this type of typical problems and concepts and tips and techniques for mensuration, as it is very important topic for CGL and other notifications also. Okay, so in some notifications that mensuration will be a major topic. Please try to focus more upon this topic. We are going very slowly, only considering non-math students. So before closing this problem, before ending this problem, I want to say you the main points of this problem once again, and then after we conclude this one. Okay, what are the main things we need to focus in this problem? Main points that we need to focus in this problem are, just listen. Here when we joined the centers of the circles, one triangle is obtained. That is not in equilateral triangle, first thing. So what type of triangle, we have to find it out. And main challenging task in this problem to identify whether what type of triangle it is. This is a right angled isosceles triangle. We have to identify in that way. To identify that it's a right angled isosceles triangle, we must have a grip over the basics of triangles. So learn basics, learn the basics. Those are only important thing. Okay. Now after identifying it's a right angled isosceles triangle, area to find out the isosceles right angle triangle is half a square, and we find it out. And then after we need to find out the area of the three sectors. For that, angle required are also provided, because in right isosceles triangle one angle is 90, remaining two angles should be 45 and 45. By using that, we can find out the areas of the three sectors, where two sectors areas are same. So finding one and making it double, and then one area would be pi into 1 by 4 into pi 1 square, that is pi by 4. And after that, summing all these areas, and summing all these areas means which one? Adding the areas of all these three sectors, and subtracting from the triangle, we get the answer. And remember students, lot of students will come and ask me that whether there is any shortcut for this problem or not. No shortcuts at all. Only analysis is a solution. So try to analyze the things. Slowly it becomes very easy. So guys, let us see one more technique from the mensuration. Just look at this. Okay, so it's a square. Okay, and the side of the square would be your A. Okay, and you need to find out the radius of this small circle. Radius of the small circle means this white circle. How to do it? Let us see. Okay. But guys, to find it directly, it's impossible. So what we have to do? We need to search for any measurement which is connecting with this circle. Okay. Let us see. I want to tell you the basic of the square. Okay. See, what is the basic of square? Let us see. For example, if it's a square, I have drawn like this. If its side is A, then what is length of its diagonal? This length of diagonal would be, just see, is this a right angle or not? Now this diagonal is dividing this square into two equal right angled isosceles triangles or not? See, when we separate this, okay, is this a triangle or not? In this is A and this is A, and this is 90 degrees. So this is right isosceles triangle, means right angled isosceles triangle. When it's a right angle isosceles triangle, then we can apply for this Pythagoras theorem also. When you apply the Pythagoras theorem, what would be this diagonal? Root A square plus A square, means side square plus side square is nothing but hypotenuse square, and under square root this is, so a square, how many a squares? 2a squares or not? Okay, so this would be under square root 2a square. Okay, what is that? A square comes out and it becomes root 2 into a is there outside. Okay, now anyhow, if you carefully observe this, if you carefully observe here, if this is a side a, then what would be its diagonal? Root 2a or not? So for a square, I am telling you the property of square because it is somehow related to this diagram. Okay, what is the property of square? If side of the square is a, then its diagonal would be root 2a. Clear? So now it's root 2a. So our next part. Now let us see. Here also the side of the square is how much? Is this a or not? That is a. This is your a. Next. So what about its diagonal? Root 2a or not? Now only we said when side is a, then its diagonal would be root 2a. That means diagonal of a square is root 2 times of its side. So now let us draw the diagonal of it. Okay, we will draw the diagonal. Now tell me, is this diagonal of this square or not? Now tell me, if side is a, now only we said that length of the diagonal would be root 2 times of side, that is root 2a. Now can we write like this or not? Let us represent this length also. This is root 2a or not? Okay. So guys, when this side is a, then length of this total diagonal is how much? Root 2a or not? So this length is root 2a. That's root 2a. Now let us see one more thing. Just carefully observe. Is this a side of square or not? Is this a side of the square or not? Now let us see. This red colored portion is nothing but a sector or not? So now let us find out, let us see what the sector radius is. Is this a radius of sector or not? Because as we are rotating like this, it's a radius of sector. Clear? This is radius of sector. That means here the radius of sector is equal to side of the square a. That is a or not? Once again telling you, here side of the square is a. Okay, side of the square is a. Now when we are rotating like this, is this a radius also or not? This is radius also. So when this is radius, this entire radius, this length is a, this is a, and this is a, and this is a. That means here radius of this sector, red colored sector, and side of the square are same. Now from this, okay, what can we say? Is this also a or not? This length up to this part. Okay, let us show you. Say, let me show you. Here this length would be, see, this length would be also a or not? A. So up to from here to here length is a. Let us represent that. So this length is again a or not? Again this is a. So guys, let us observe what the analysis we have done on the diagonal. Okay, so as first of all, as the side of this square is a, its total length of the diagonal is this root 2a, and as this side is equal to the radius of this sector, this portion means up to this, it's a. Okay, now what about this rest portion? Let us do analyze. See here, is this a circle or not? For this there is a center. Okay, there is a center for that circle. So let us suppose this be a center. Okay, and we need to join the radii. Okay, let us join the radii again. Okay, when we are joining the radii, see here, I am joining the radii. This is radius, and this is one more radius which is perpendicular to that. Okay, now this is radius and this is also radius. These two are two radii. Now let us represent them. This is radius, this is radius, and this small portion is also radius. Clear? Now what we got is, we represented the radii of the circles. Now we need to analyze this part, because already this is A. Already this is A. So we need to analyze this part to get the radius. Let us see. I'll separate this diagram on the board and we'll observe. Now let us do observe this. Let's observe. Here what we have given is this green line a diagonal or not? So this is root 2a. Next, as this is a radius of the sector, red sector, this is a, and this is a radius of this small circle, let it be some small r. As we said, this is small r, right? Okay, now we need to find out this entire green length. Is that right or not? Now let us do something to this diagram. I mean here, observe this. Here this is R, and this we need to find to cover the entire length. Getting my point or not? So here this is R, and this is R, and this is R, and here some diagram is appearing over there. What is this quadrilateral? Tell me. I am telling you, this is a radius and this side is acting as a tangent. Just see here. Okay, this side is acting as a tangent now. Okay, so tangent will be obviously perpendicular. This will be perpendicular, and this will be perpendicular. This will be perpendicular, right? So is this a square or not again? And what is the side of the square? R or not? Okay, this is R again. Just see. Okay, now let us see this. Now this is R, and the side of the square is R. Side of the square is R. Then what is its diagonal? Root 2R or not? So this entire length would be root 2R. Okay, so let us write this here. Up to here this is R, and this total length would be how much? This length means this one. This one is diagonal of the square, which is root 2R. Now our analysis is finished. Now let's see the let us once more observe this. Now this entire length is how much? Root 2a. This entire length is root 2a. Now this segment is how much? A, and this segment, I mean this is a radius, that is r, and this is a diagonal of the smaller square obtained, that is root 2r. Now tell me, see, this entire length is equal to this length or not? Means this diagonal length is equal to sum of the three segments or not? This segment plus this segment plus this segment equal to total diagonal length or not? That's it. So what we have to do here, total diagonal length is equal to, okay, what we have to write here, a plus r plus root 2r, isn't it? Is this right or not? Okay, so now let us write down the result. Now here what we wrote here, root 2a equal to, okay, a plus r plus root 2r. Clear? So now I mean I'm taking the a to this side, then this would be root 2a minus a. Now this equal to r plus root 2r. Okay, now taking common a from these two terms, it would be, okay, root 2 minus 1 into a, and taking common r out of these two terms, this would be 1 plus root 2. 1 plus root 2, we can write this as root 2 plus 1 into r. Okay, now if you see, we need which one we need to find, r or a? We need to find r or not, where r is a radius of small circle. Now how can we find this r? To find out this r, we send this root 2 plus 1 to another side of the equation. Now what do we get? R equal to root 2 plus 1 comes under the denominator. Now root 2 minus 1 by root 2 plus 1 into a. Now what is your finally radius of the small circle, boys? Here radius of the small circle is equal to root 2 minus 1 by root 2 plus 1 times of a, where a is what? Side of the square. A is what? Side of the square. I think you understood this. Once again, I am giving you a small explanation to understand this technique. See here, when this side is a, okay, this entire diagonal is root 2a, means this length is this length. I am showing again, this length means this one. This length is root 2a, and as this is a radius and radius is coinciding with side, means radius is equal to the side of the square. This length up to here is a. Now we analyzed this. This is r, and this is, as it is a diagonal of, see, observe this one, as it is a diagonal of square, small square, when side is r, diagonal will be root 2r. So here root 2r plus a means this total length is equal to sum of this segment plus this segment plus this segment, where this is a, this is r, this is root 2r, as we said before. So summing all them, here we are getting root 2a equal to a plus r plus root 2r. Separating the like terms, and we can find out the radius r as how much? Root 2 minus 1 into root 2 plus 1 into a. Guys, this is a finest shortcut. Okay, here we should find like this. See, in the time of preparation, you should analyze like this. After once you analyze, you can use this final result as your shortcut in the examination. So finally, what is our conclusion? So what's our conclusion? Whenever we have given this type of diagram, means in a square, okay, one sector is described with its radius equal to the side, radius equal to side, okay, and another circle is drawn which is touching the sector and the sides of the square, which is touching the sector and sides of the square. Then if the length of the side is equal to, if the length of the side is equal to a, then what is it in the radius of this smaller circle? This is equal to how much? root 2 minus 1 by root 2 plus 1 into A. Means when simply what can you do whenever the side is given, okay, whenever the side length, suppose 2 centimeters square, side of the length is, so length of the side is 2 centimeters. I said length of the side equal to 2 centimeters. Then find out the radius of this small circle, how much it would be. Simply we have to substitute 2 in place of this. What is the final value? Root 2 minus 1 by root 2 plus 1 into 2. That's it. You can make it simplified, you can get the answer. Is it simple or not? I am telling you that only. Once you analyze and keep that result within your mind, then it can be very easy. It will be very easy for you to tackle any question in the examination point of view. And of course, for this technique also, I'll provide you one exercise in my next video. Okay, please guys, focus on this. If you are really interested to see these videos, depending upon your comments, we are going to upload this type of videos, many more videos, like number of videos we are going to upload for this type of techniques. Okay, from mensuration and geometry, because these are the very important areas to crack the CGL exam. So we are going to target on the CGL notification right now. Okay, I think you got it. Okay, finally, if side is A, what is the radius of the smaller one? Root 2 minus 1 by root 2 plus 1 into A. So guys, next we'll do one more technique on mensuration, which will be useful for solving lot of problems. Okay, based on this equilateral triangle, this is one more technique. Once again remaining, this is technique, not problem. Okay, based on this, I'll provide you the exercise in my next video. Okay, so now let us see. Here, it's an equilateral triangle. Okay, this is an equilateral triangle. Okay, in this equilateral triangle, P1, P2, P3 are the perpendiculars drawn to sides. Suppose P1 is a perpendicular drawn to this side, and P2 is a perpendicular drawn to this side. P3 is a perpendicular drawn to this side. Likewise, okay, these are the perpendiculars drawn to sides. And what is our target? Then we need to find out the length of the side. Then we need to find the length of its side. That's written in the statement also. Okay, once again repeating this, when perpendiculars drawn to sides of an equilateral triangle from any internal point, this white dot is there, no, this is some internal point randomly drawn. Okay, so this is some internal point. From there we have drawn the perpendiculars to the sides of an equilateral triangle, and we need to find out side of the triangle. This technique or this shortcut will be helpful while solving lot of cases while doing the problems. How it will be helpful, I'll show you in the exercise video. Okay, now let us analyze the technique and let us see that what the side will get. Okay, before going to that, I want to explain you this very slowly. Let us observe what it is. For example, now here we need to find the side, no? Let the side be x. Let the side be x. So this is also x. This also would be x. So I'm showing you here, this is x, this is x, this is also x, because it's an equilateral triangle, all the sides are equal, right? We are considering, we have to find out the side, and we are considering this as x. That's our first assumption. Now for finding the side, I am going through one procedure. Try to observe what it is. Okay, I want to find out the area of the triangle. If side is x, what is the area of the triangle? Root 3 by 4 x square. Is it an area of triangle or not? It's an area of the triangle. when it's an equilateral triangle with side x. So okay, area of the triangle. Now for my convenience, I want to find out the area of a triangle in a different way. Why I am doing this all? Final, don't confuse. Our final target is to find out x. That means side of the triangle. So I want to do that in another alternative procedure also. How we will do? Just see. Okay, let me partition the diagram. Okay, let me divide this into some pieces. How we divide this? Just see. I am joining this point to this corner, this point to this corner means vertex, and this point to this vertex. What I did? From that point, I joined all the vertices with the help of line segments. Okay, now what can you observe here? We can observe here that by these yellow lines, see, I am drawing this with yellow. By these yellow lines, how many triangles are separated from the bigger triangle? Just see, how many triangles are separated? See, you can observe this or not. You have to see my showing, pointing the pen. Okay, so see here, see, this one is one triangle or not, and this one is another triangle or not, and this is third triangle. So by using this yellow colored lines, how many triangles are separated? 3 triangles or not? Suppose I'll tell you that if you find out the area of each and every triangle and adding all them, do we get the area of bigger triangle or not? I'll show you on the diagram. Here we find out the area of this triangle, and we find out the area of this triangle, and we find out the area of this triangle, and adding them all, we get the area of the bigger triangle given or not. So we do that also. Okay, partition. Before that, let us observe each and every small triangle. Let me separate this. I'll draw here. Okay, now just see. Okay, here I am taking this first triangle like this. Is it looks like or not? Looks like this or not? I have taken out this here. Okay, now what is this? Is this x or not? This length would be x. Now what is the length of this perpendicular given? P1 or not? P1. Now what's our next target? We have to find out the area of this triangle. From the basics of mensuration of the triangles part, we have one formula that when base means one side of the triangle is given and altitude drawn to that side. Altitude means this is altitude. Altitude is height itself. So height drawn to that side is given. Then what is its area? Half into base into height or not? Half base height. In that case, we can find out is it a triangle or not. For this, what is base? X, and what is height here? P1, right? So now, if you see carefully observe all this, here this is x means for this triangle, okay, this x is a base, and this is height, and for this triangle, I'll show you here, and for this triangle, okay, this is a base and this is a height. So from after observing all the diagrams, what did you got? Here sides of bigger triangles are acting as bases. Okay, bases for the small triangles separated. Okay, and remaining P1, P2, P3 are the heights of the respective triangles. Now we are going to find out the area of each and every triangle of them, right? Okay, now here for this triangle, what is the area? This is base, this is height, means area 1 is, okay, half into base is x and P1 is height. So its area would be half x P1. In the same case, if you want to find out the area of this portion, means this triangle, see my pen, movement of the pen, do observe. Okay, this triangle would be, okay, now what is the area of this? X is a base and P2 is a height. Then what is the area of this part? Second triangle would be A2 equal to area 2. Area 2 would be how much? Half into base is X, and this would be P2. So this is area of the second triangle. This is area of the first triangle. Now let us move on to third triangle. What is third triangle? This is, okay, base, and X is the base and P3 is a height. Then what would be your area? Now A3 equal to, okay, half into base is this X and height is this P3. Okay, now third area is half X P3. Okay, half X P3. So what we did, just for small repetition, just I am giving you small repetition here. For this triangle, area is half X P1, and for this triangle, the area is half X P2, and for this triangle, this one, okay, area is half X P3. Now we could find all the individual triangles separately. Now if you want to get the area of this bigger triangle, what we need to do? I think people got it. How to do it? Here we need to add all these areas to get the bigger triangle area. Okay, now we do that. Okay, now area of this triangle is again given as how much? Okay, again this area of triangle, area of the bigger triangle is given as how much? Half X P1 plus half X P2 plus half X P3. Now we can take X by 2 in common from all of them or not. Here X by 2, X by 2, X by 2 can be taken common. Now let us take common them. X by 2 times of what? P1 is left inside, next term P2 is left, in next term P3 is left. Now this is also the area of this triangle, means this is also the area of this triangle, and this is also the area of a bigger triangle, right? So here we find the area of given bigger equilateral triangle in two different methods. Okay, anyways, whether you find by this method or by you find by this method, anyhow area remains same for the triangle or not. So we can equate these two or not, because this is also the area and this is also the area. Anyways, these two, in both the cases we are finding the area of the same equilateral triangle. Get it? So now what can we do further? So here we can equate these two or not. Can we equate these two or not? Let us do that. Now what we are doing here, root 3 by 4 x square is the area where x is the side of equilateral triangle, and on other hand, okay, when P1, P2, P3 are the perpendicular down to the sides of the triangle from internal point, that internal point may be anywhere it may be put. Okay, so now at that time what the area we got? Okay, what the area we got here? X by 2 into P1 plus P2 plus P3. Now we have equated these two. Okay, this area is when P1, P2, P3 are the perpendiculars taken, and this when x is considered as a side. Okay, anyways, what we are going to do, we have to find out the x or not. So we have to find out the x. Can we cut here x or not? Because if you take this x to this side, x square by x would be x only. So I am cutting directly. Now this 2 can be cancelled on both sides on denominator part. So 2 1s are and 2 2s are. Right? So now what is left here? Root 3 by 2x equal to P1 plus P2 plus P3. So now x equal to how much? This 2 by 2 will be go on to do a numerator part, and root 3 comes to denominator part on changing to another side. So now this would be 2 by root 3 times of P1 P plus P2 plus P3. So now what is the value of x we obtained? 2 by root 3 times of P1 plus P2 plus P3. Isn't that our answer? Is this not our answer? What we are asked to find? We need to find out the, we need to find out the side of the triangle or not. That's it. X is a side we took. Okay, we considered x as a side. We have taken. Now we got the value of x or not. What is that? 2 by root 3 times of P1 plus P2 plus P3. So finally, what is our conclusion? When P1, P2, P3 are three perpendiculars drawn from any internal point in the triangle to the sides, then the value or the length of the side would be 2 by root 3 times of P1 plus P2 plus P3. Got it? So like that we need to do. And for finding that, once again, just a small explanation giving for this brief part of this one is what we did. Okay, we did here, we find here area of the equilateral triangle when x is a side, that is root 3 by 4 x square, and we separated by using these yellow lines, and those are three triangles. Separately those three triangles areas were, okay, half x P1, half x P2, half x P3. Adding all them we get also, okay, this bigger triangle area. Okay, in both the cases we are finding the area of the same triangle. So root 3 by 4 x square will be equated to half x into P1 plus P2 plus P3. Thereby, on simplifying that equation, we got a value of x, which is our side. That is our analysis to find out this. But remember guys, if you want to do the problem in your examination, if you involve this much procedure, don't you take the time of more than 5 minutes? It's a waste of time, no? So to save your time, we are choosing this as your shortcut. So finally, what is our conclusion? Conclusion would be when P1, P2, P3 are the perpendiculars drawn from any internal point, it's not a particular one, any internal point, to the sides. P1 is to this side, P2 is to this side, P3 is to this side. Like that, P1, P2, P3 are the three perpendiculars drawn from any internal point to the sides of equilateral triangle. That is must be underlined. For which triangle it is? Equilateral triangle only. For not all types of triangles it can be applicable. Got it or not? For equilateral triangle, then we can find out the side also, and value of that side would be, now I'm going to finally use the result, that would be 2 by root 3 times of P1 plus P2 plus P3. While writing the examination, okay, if some question is given related to this, do we need to involve all the procedure as we did before is required? Not required, no. We don't need to involve such a big procedure. We just need to remember this value. When P1, P2, P3 are the perpendiculars from any internal point to the sides of equilateral triangle, then its side will be equal to what? 2 by root 3 into P1 plus P2